Good morning, everybody. Okay, so we're going to go through 5-7, which is pages 114 and 115 in your packet. I'm going to try to go through these a little quicker. I'm getting some feedback that some of my videos are a little bit long, and that you can go back and look at it if I'm talking too fast. Okay, test cramming problem. Jerry begins cramming for algebra tests at 10 p.m. on Wednesday. Okay, I'm sure none of you do that, but maybe you know somebody who maybe crammed for a test at the last minute. Her grade depends on the number of hours she studies. She figures that with no studying, she would get a 40%. With 1 hour of studying, she'd make 75%. And with 2 hours, she might get a 90%. Assume that her grade is a quadratic function of the number of hours. So if grade is a function of number of hours, remember the y is always a function of x because y is dependent, x is independent. So your x is your number of hours studying. Your y value is the grade on the test. So your grade on your algebra test. Okay, and let's look at the information that they give us. So with no studying, number of hours studying is 0. So let's make an ordered pair, 0. Her score, the y value, the grade, would be a 40%. With 1 hour of studying, she'd get a 75%. And with 2 hours of studying, she'd get a 90%. Okay, we have to come up with a quadratic equation. You can always come up with a quadratic equation if you have any 3 ordered pairs. So we know the general equation for a quadratic equation is y equals ax squared plus bx plus c. Okay, so plugging this in, our y value is 40. We're plugging in 40 for y and 0 for x. Okay, in ordered pairs, x, always x comma y, equals a times 0 squared plus b times 0 plus c. This equation, the y value is 75. So 75 equals a times 1 squared plus b times 1 plus c. And here, the y value is 90. Equals a times 2 squared plus b times 2 plus c. Okay, let's simplify. This becomes, that should be a 40. Sorry, 40 is your y value, 40. So that should be 40 equals a times 0 squared plus b times 0. Those both go away to 0. You get 40 equals c. Okay. Here you get 75 is equal to a times 1 squared plus b times 1 plus c. So that's just a plus b plus c. Notice we're not solving for x, y, and z. We're solving for a, b, and c. Once we get a, b, and c, we can plug them back in here, and then we have our quadratic equation. We're solving for the 3 constants in our equation. Here we've got 90 is equal to a times 2 squared, so 4a, plus b times 2, so plus 2b plus c. Okay, now these 2 middle equations, we know that c is 40. So if I plug in the 40 there, I've got 75 equals a plus b plus 40. And here I've got 90 equals a 4a plus 2b plus 40. Okay. And let's simplify this equation. So that could get subtracted over there. So then I get 35a equals, 35 equals a plus b. And from this one, I'll subtract 40 from both sides, and I get 50 equals 4a plus 2b. Okay. And next thing, we get, let's eliminate one of the a's or the b's. So if I take the first equation and multiply by a -2, okay, I'm going to come down here. So -2 times my first equation, 35 equals a plus b. And then I've got, bring down the second equation, 50 equals 4a plus 2b. Okay, so that's -70 equals negative 2a minus 2b. And I've got 50 equals 4a plus 2b. Simplifying, I'm going to get 50 minus 70, negative 20 equals 2a. So a is going to equal negative 10. I already know that c equals 40, a equals negative 10, and I've got this equation over here, a plus b equals 35. So 35 equals negative 10 plus b. So b is going to equal 45. So plugging those three things into this equation, my equation becomes y equals ax squared, so negative 10x squared, plus bx, b is 45, plus c, so plus 40. And there's your equation, okay? Now, I actually already took this equation and I plugged it into my calculator. We're going to use this. So now we're going to use the calculator to figure out everything else. Now that we actually solved for the equation by hand, we solved that system by hand. So if you go to tab, you can see I typed this in there. Y equals negative 10x squared plus 45x plus 40. Okay, and this is the default window. That's not a great window. Negative 10 to 10, negative 6.67 to 6.67. You want to think about what these things mean. You're not going to study negative 10 hours. You're probably not going to study 10 hours, okay? But we can look over here, and then your y value, this only goes up to a score of 0.67. Let's go to our window. So you hit menu, and go down to window/zoom, and you want to go to, sorry, that went, window zoom, hit enter. And let's just do window settings. Okay, so our X, we don't need to see back there. Let's just go 0 to a maximum 10 hours. That's fine. Our Y min, we can leave that one alone. But we want to know our score can go maybe up to 100. So let's put 110. We can see a little pass there. Okay, so you can see what's happening. And you can study. Actually, you know what? I'm going to go to menu 4, 1. I'm going to say negative 3. I want to see my y-axis, so I'm going to go a little bit to the left. Okay. So now you can just double check. It's always nice to be able to double check that you did this right. We can do a trace, which is menu 5-1, menu, trace, graph trace 1. Now I'm in trace mode. I can type in any x value I want. I type in a 0, hit enter. See what it does. It gives you that 0, 40, which was our given point. We know we got that right. If we look at our points, 0, 40, and then I can type in 1, hopefully get 75, 2, hopefully get 90. 1, and I got 75, 2, and I got 90. Okay, looks like we're pretty close to our maximum score. Sometimes you can only do so much with cramming, okay? Maybe you can't always get 100% by cramming the night before. Okay. Predict Jerry's grade if she studies for 4 hours. So I'm in trace mode. I'm just going to type in a 4, hit enter. Okay, 4 hours, she's only getting a 60%. Okay. Is that realistic? I don't know. Maybe you studied 10 o'clock, maybe you stay up to 2 a.m. and your score starts going down because you didn't get enough sleep. Or maybe this doesn't make sense. Maybe this function only works over a given domain. Maybe it only works from 0 to whatever hour gets you to your maximum score. Maybe a little past, because maybe then you start to lose some sleep and your score actually might go down. Okay, we don't know that for sure based on this function, but we for sure know that if you're going to study more than this many hours, your score can't go negative. So we definitely know that our domain has to be cut off somewhere. Okay. How long must Jerry study to get 100? Okay, let's type in y equals 100. So you go to the tab button. You can put another function in, y equals 100. Okay, that's up there. These never intersect. Okay, there is no amount of hours Jerry can do at this point to get 100 on this test. How long must she study? I would just say not possible. So for C, not possible. There's no number of hours she could study at this point, cramming to get 100%. How long must Jerry study to make the highest grade? So we want to find this vertex. It actually looks like it's showing us the vertex, but let's verify that. Let's go to menu, and we go to analyze graph, number 6. And we want to find the maximum. Since this is a parabola opening down, it's going to have a highest point. And that highest point, the y value, is your score, and that's what you're looking for. So 3. So we're going to go, first I have to tell it which graph I want. I want the maximum on this graph. So now it gives me a lower bound. I go over to the right, upper bound, hit enter. And that is there's our vertex, 2.25 hours, so 2 hours and 15 minutes. Will get her a score of 90.25. Okay, so 2.25 comma 90.625. Okay, so how long must she study? 2 hours and 15 minutes. That's 1/4, 0.25 of an hour, 0.25 of an hour. And will of studying, let's just write it all out, of studying will get Jerry a score of 90.625. Okay, maybe that rounds up, maybe it rounds down. We don't quite know the story. So what is the highest grade? Okay, then that's the 90.625. Okay, so once you come up with the equation, everything else you're going to do is basically off the calculator and using stuff on the calculator. Okay, so she studies 4 hours. I don't know if that's realistic or not. Staying up till 2 maybe drops your score 30 points. That would be terrible. Okay, she can't, not possible to get 100. 2 hours and 15 minutes is how long she must study, and the highest grade is 90.625. Let's do one more. You might want to stop the video now if you think you understand it, but I'm going to go through the next one. And if you want to just go try it on your own, and when I'm done, you can go back, or you can just check the answer key. Okay, but I'm going to go through this problem. Local pizzeria publishes the following menu. Small pizza, 8 inches in diameter, is $7.10. That's like a small pizza, but that's still a really cheap price. 10-inch in diameter, $8.90. 13-inch in diameter, $12.50. Assume that the price you pay is a quadratic function of the diameter. So the price you pay, y, is a function of x. Okay, define your variables. X is the diameter in inches of your pizza, and y is the price you pay. Okay, use the ordered pairs to find the particular equation of the quadratic function. Okay, so your ordered pairs are in x comma y. Your first one, 8 inches in diameter, gets you a 710 pizza. If you need to double check, it's nice that you wrote this down. The 8 inches of diameter, that's your x value. So 8 comma 7.1, put 7.10, but 7.1. 10 inches in diameter is going to be $8.90, 8.9. 13 inches in diameter, 12.5. Remember, y equals ax squared plus bx plus c. So your y value, 7.1, equals 8 times x squared. Your x is 8. 8 squared is 64. A, remember, that's your x value. So your variable is going to be the a. Plus b times x, b times 8, 8b, plus c. And that c is just 1c, so your coefficients are 64, 8, and 1. The next one, 8.9 is equal to ax squared. X is 10, so 10 squared is 100. 100a plus bx, so b times 10, 10b plus 1c, and 12.5 is equal to ax squared, a times 13 squared, 169a, plus bx, 13b, plus c. Okay, so now from here, we're going to just solve this on our calculator. Okay, this one you could do by hand. I probably wouldn't make you do one by hand this messy, especially on a test. So let's go to our calculator. This one I am going to actually do on this calculator. You can see it a little better. So I'm going to add a calculator page, and we're just going to use the Solve System button, which is Menu, Algebra, Solve System of Equations, 3 equations. We could leave A, B, X, Y, and Z, but let's make A, B, and C. A, B, C. And now here's our equations. You can type it in any way you want. I'm just going to type it in the way I wrote it. 7.1 equals 64A plus 8B plus C. Next one, 8.9 equals 100A plus 10B plus C. Next one, arrow down, 12.5 equals 169A plus 13B plus C. Okay, you're solving for A, B, C. Let's just double check. I don't want to make mistakes. Okay, hit enter. Okay, so here's your values. So what you end up with, and I always write these down, A equals 0.06, B equals negative 0.18. Now, if you arrow up to this, you can arrow to the right, and you can see that C value. C equals 4.7. Okay, so coming back to the paper. So we've got A, B, and C. We know that Y equals AX squared plus BX plus C. So Y equals A value 0.06, X squared plus, plug in the, or minus, so minus 0.18x plus 4.7. So there's your equation. Plot the graph of this function on your Inspire in the domain, so x goes from 0 to 20. Use a suitably large vertical window, sketch your results. You've got to think about how big you want your window to be. By x values, the diameter goes all the way up to a 20-inch diameter. Your price, if these are going up in this fashion, 20-inch diameter, remember that the area of a pizza is pi r squared, so it's a quadratic relationship. So that's probably why these values are going up so quickly. Okay, I'm going to go and plug this into here. I'm going to create a new page. Control Doc does a plus page. That graph. So y equals 0.06 x squared minus 0.18x and then plus 4.7. Should I type that in right? Okay. Hit enter. Okay. So this window doesn't make a ton of sense. Let's go to our window. Menu, window. I like to do it by hand and just plug them in myself. And so your x, we said 0 to 20. I like to go a little less than 0 just so I can see the y-axis. -2 to 20. The y value, I'll leave that negative. Let's go -2 to what price? Maybe $30, I'm guessing. You can always adjust this. That looks like it's okay. Okay, so here's our graph. So if we plot this, we can plot some values. Again, that trace function is so great. Menu 5, 1. Now I can plug in any x value I want, hit 0 and enter. Notice over here, you've got the 0, 4.7. How high do I want to go? Okay, it told us it wanted to graph this on our page from 0 to 20. Let's just kind of scale this, 5, 15. And this will go up to, I don't know, what did I go up to? I went up to 30, and it looked like that was enough. 10, 20, 30. My y-intercept I said was 0, 4.7. Okay. Now let's go back. You can plug in other values. Maybe you want to plug in every 5. So you can type 5, hit enter. We're still in trace mode. Notice this thing up here tells you you're in trace mode. Okay. 5, enter 5, 5.3. Plot that on your graph. Let's type in a 10. Hit enter. 8.9. 8.9. It might make sense to plug in an 8 just because that's one of our actual pizzas, 8, 7.1. We can see, we know we did that right because that's what it should be. And then we can type in the 13-inch diameter and enter 12.5. So we know we did that right. You're just kind of estimating on your graphs. 13, 12.5. I'm curious if you have a 15-inch pizza, how much is that going to cost? 15.5. That's right here. Let's go to what happens at 20. 25.1. Okay, let's go back to my page. You can see what I just typed in. I typed in these points and I labeled them out, 20, 25.1, and we can kind of see going through these points. I did my best to eyeball it. It's not perfect. So 5, 5.3. Of course, doing this freehand is not the easiest. Okay. If a pizza made other sizes of pizza, how much would you expect to pay for a 20-inch boss size pizza? Well, that's this one, 20 inches, the Y value. Let's label this price. And this would be diameter in inches of the pizza. That's your x-axis. So you would expect to pay $25.10 for a 20-inch pizza. The menu listed a pizza for $19.50. What would you predict the diameter to be? So that's a Y value. So really we're solving the equation 19.5 equals our equation 0.06 x squared minus 0.18x plus 4.7. You could subtract 19.5 from both sides and use the quadratic formula. Or since we've got the calculator, let's go back to the calculator. We want to know when the Y value is 19.5. So let's type in another equation, tab, Y equals 19.5, which is just a horizontal line. And now we find the intersection. So menu, you could do menu. We could do this through geometry, which we've done before, or we could do it through analyze graph, intersection. Now this one, you're not clicking on both of the curves. This one, you're giving it a lower bound, so somewhere to the left and somewhere to the right, and it gives you your intersection. Okay, so at 9, if it's 19.5, 1950, it's about 17.28 inches in diameter. So x would equal 17.28 inches in diameter. What does the price intercept equal? Okay, mine are a little goofy. It looks like this actually, the vertex is a little bit below here. That's interesting. If you look at this, it looks like the vertex is over here somewhere. I'm curious. It doesn't ask, but let's find the vertex. Analyze graph, and it's a minimum because we're finding the lowest point. Because the parabola opens up, that lowest point, that vertex is a minimum. It's a low point. So let's go, we want minimum on this graph, lower bound to the left, go to the right. So there's our minimum, which is interesting. Okay. So it looks like there is a short amount of time or diameters where your pizza is getting bigger, but the price is getting smaller. But think about that. It's only when your diameter is 1.5 inches. And have you ever seen a pizza place to order, to offer a pizza where the diameter is 1.5 inches? Not really practical. So I'm guessing that this domain would be somewhere bigger than that. Okay? We don't know enough information to answer that question. Okay, but they do ask us, where's my paper? They do ask us, what does the price-intercept equal? So the price-intercept, the price is your y. So we really want the y-intercept. And here's our y-intercept. The y-intercept is 0, 4.7. And what does that mean in the context of our problem? Well, x is the diameter of the pizza. So it means when the diameter is 0 inches, basically there's no pizza at all, the price is $4.70. Okay, so what does that mean in the real world? Well, I don't know. It's hard for us to know, but that could be a base amount that you're going to pay to order any pizza off the menu. Maybe that's the cost that they need for, the pans and the labor and the oven. Maybe that's a base amount before you even get a size of a pizza. Or if you're ordering over the phone, maybe that's a delivery cost. We don't quite know how their cost is set up. Okay, so I would say possibly, I would say it's a base amount of some sort. Possibly a delivery fee. Or could be some kind of operational cost for the the labor and the everything else that's involved. Okay, and that's all, folks.